Good afternoon, everyone. Welcome to the Lunch and Learn hosted by Wavelogix. My name is Suzanne Florick, and I'll be your host today. We're thrilled to have you join us for an insightful session on the importance of advanced monitoring tools in large-scale engineering projects. Before we dive in, I've got a few housekeeping items to run through with y'all. This webinar is being recorded, and a copy of the recording and any presentation materials will be shared with you via email afterwards. For the best viewing experience, we recommend using gallery view. You can switch between the views in the upright corner of your Zoom window. Please use the Q&A feature at the bottom of your screen to submit any questions you have during the session. We'll address them during the Q&A portion at the end. If you encounter any technical issues, let us know in the chat and our support team will assist you. It's my pleasure to introduce you to Wavelogix and our distinguished speaker for today. Wavelogix was founded in 2021 in partnership with INDOT at Purdue University to improve road and bridge reliability while reducing traffic disruptions. The Rebel concrete strength sensing system provides real-time, in-place measurements of concrete properties, offering a more precise and versatile solution than traditional sensors. With patented technology, Wavelogix eliminates the need for preset maturity curves, delivering accurate results across various projects and helping teams optimize schedules and reduce costs. Joe Turek is the president and COO at Wavelogix. Joe received a bachelor's degree in electrical engineering from the University of Notre Dame and an MBA from Northwestern's Kellogg School of Management. He's been involved in manufacturing his entire career. He holds 5 patents involving high-performance microwave telecommunication circuit board technologies, and he's a registered professional engineer and a member of IEEE. Jesse Jonas is a registered professional engineer in Illinois, Missouri. Welcome, Jesse.
Thank you.
He owns and operates All Civil Engineering LLC, where he supports the Concrete Council of St. Louis and the Illinois Ready Mix Concrete Association by providing technical education, technical support, and general concrete market promotion. In previous positions, Jesse has held government roles of construction manager at Missouri Department of Transportation, St. Louis County Department of Transportation, as well as private sector roles, including business unit leader for civil engineering firm Horner and Schriffen, and finally serving the Missouri-Kansas American Concrete Pavement Association as Director of Engineering and Interim Executive Director. Jesse resides in St. Louis, Missouri with his wife Natalie and their 3 college-age children. Welcome, Jesse.
Thank you so much, Susan.
So with that, Joe, let's get started.
All right. I'm going to stop sharing the screen right now so that we have a bigger picture of all of us here. And Jesse, it's a pleasure having you here and chatting with you again. Let's get a little bit into your career and your perspective on concrete. Share with us a little bit about your journey and how you got and started in all civil engineering.
Sure. So as you could tell from my bio, I can't keep a job, so I figured I better start my own company. Can't fire yourself. No, I have had a very blessed career, getting to spend a good 11 years with Missouri Department of Transportation and being a part of some major infrastructure projects. And then I got to taste the local community working with St. Louis County and experiencing infrastructure improvements from their perspective. Also spent some time while at the county with their material lab, running the material lab for the county. So I got the materials aspect side down too. From there, it took me into working in the private sector, where I had a really good opportunity with a great company, Horner and Schifrin. We ended up doing the same kind of work, construction division management, throughout a couple states, and getting to kind of spread that out even a little bit further. From there, an opportunity to join the non-for-profit world came along, and American Concrete Pavement Association was a group I was well familiar with. And from there, I got to help out in a lot much more broad spectrum instead of just working for one agency, one DOT. I was able to help and support communities, across multiple states. So that was very exciting. All of that experience kind of blended into kind of a diverse background of knowledge and challenges and opportunities. And all of that led into I was at the right age at the right time. And if I was ever gonna do something like start your own company, it seemed like the right time. And we did that based on faith and prayer. And it certainly has been a amazing journey thus far. And I'm very grateful to continue to support the concrete industry in this role.
That's fantastic. And you work with your wife, correct?
Yep, she's my boss in every way, shape, and form now.
Oh, that's amazing. That's great. Does she have a concrete background as well, civil engineering?
She's business marketing.
Okay, great combination for
Yep.
you're she's the brains and you're the brawn, right?
She's everything. And
And do you have kids in the business yet?
no, we got three college age kids, so
Okay.
potentially someday.
Okay, good. Any of them studying civil engineering?
My youngest is, so we do have one. Yeah,
Yay. Okay,
yeah,
great. We keep the growth going. Fantastic.
absolutely. Legacy.
Yeah. So tell us about like what do you do on a regular day? I mean, what happens to Jesse on a normal day?
So, yeah, it's anything and everything. Basically, my main role in the company is to support the concrete industry. So in a day, I'm working with contractors, ready mix producers, cities, state, and we're talking pavement, we're talking opportunities, we're talking materials, uh, just working through all of the engineering side of concrete. And
That's it. Yeah,
concrete
from a
is
consulting basis, right?
yeah, and what I'm sure you're aware of, concrete is the second most consumed material in the world. Only water has it beat. So there's a lot of concrete that is in our built-in society. So a lot to talk about, a lot of places to be, a lot of support needed, and
Yeah.
so that's my typical day. Now, my other guys, they're running projects. They're out out doing all the things I did those first 20 years,
Yeah. Yeah. So do you go out to the projects sites today,
if
still?
needed, if
Yeah.
needed.
Okay. But
Now I
and
go out to a lot of project sites for the members.
okay. Yeah.
Yep.
Yeah. So you had mentioned you work both in the private and the public sector. And do you have a preference on one or the other or advantages or uh,
They're both extremely rewarding careers and they have their unique challenges, very different one from the other. But you've got the political side when you're on the government that, you're working with, and then on the private side, of course, you don't have the support and the if something goes wrong, it's there's no major infrastructure behind you to chime in. So they're both very rewarding careers,
yeah.
and I think whoever's doing the government side, I thank them for their service. Like I thank all
Yeah.
all, all workers for their service.
It's a team effort. It's amazing how many people put together our infrastructure and when you're just driving on the road, you're just pissed off that there's traffic and you got delays, but you don't appreciate what's really going into building a good infrastructure.
That's one of the
Everything.
hardest parts about being a government worker is you're not there quick enough, and then when you're there, you're messing up the drive. So you
Yeah.
can't win. You can't win.
Yeah. Do you concentrate mainly on horizontal kind of work, or have you done like vertical stuff as well?
My career background is largely flat work
Mhm.
with St. Louis County. The highway department would also be tasked with overseeing building construction. So we did have some vertical. And now in the Concrete Council, Illinois Ready Mix life, a lot of the projects will go see your vertical wherever
Yeah.
concrete goes.
Yeah, great. Well, let's talk a little bit about our concrete strength and Rebel. Of course, our Rebel product is revolutionary in terms of being able to give you real-time strength that the concrete is curing using a new piezo wave technology. It's the classic has been compression brakes or beam brakes and some maturity sensors as well came along about 15 years ago, have been being used. What's your experience been with mainly dealing with strength? How have you
So
tackled that?
historically, strength is, in my experience, has been cylinders and compression tests. It could be coring and compression tests, capping and braking. Very little in Missouri is done with beams
Okay.
anymore. I think largely across the country, those are starting to fade away.
Yeah. I
But a
think we're
lot,
just down to two states now that are still using beams and
I,
the FAA, right?
yeah, and the FAA. That's right. Yes.
Uh,
Yeah. So that's been largely the background of what's been used in the past. We have used maturity for early strength opening stuff. You need to do a repair in 4 hours, things like that.
yeah. And we always talk about the inaccuracies sometimes of cylinders, the
Hmm.
technique of making them. People don't always follow the practices. You got to move them from the job site to the lab. There could be a lot of variability. Is that true, or are we just making that up?
So there's certainly there's a lot to unpack there. We definitely know that there's human involvement in that, and a test needs to be run a certain way. You need to test the material at a certain time, and then that material that's used on site needs to remain that material that was tested.
Mhm.
And sometimes that can be challenging. And then we get into the summer months. So we
Mhm.
know that a cylinder test is meant to prove that the concrete itself is still the concrete that was approved. It's not
Mhm.
meant to say what's happening on grade. There's a
Mhm.
whole slew of other things going on out there that
Yeah.
that cylinder can never represent. So, so we know when we hit the June, July, August, summer months, if we're going to end up getting low break panic calls, those are the months they come in because
Mhm.
those are the hot months and those cylinders are exposed outside of the ACI requirements for a day
Mhm.
to 2 days. And we've got a lot of research and study that has well shown the strength loss that we get if they stay out in a hot day for 1 day, 2 days, 10 days, 28 days.
Yeah, that's interesting. Yeah.
Hmm.
That's yeah, it's hard to control the weather when you've got a project outside.
It
Yeah.
is. Sometimes it's hard to find shade.
Yeah.
Sometimes it's hard to find flat space.
Mhm.
Sometimes there's just a lot of
A
challenges.
lot of challenge here. The other thing we've talked about, and certainly our CEO, Dr. Luna Liu, she'll allude to the fact that the structure, when you have so much more mass and heat, when you're trying to get a 4x8 cylinder to represent the heat inside that structure, sometimes is not a good comparison and will lead to sometimes your cylinder breaks not necessarily matching what your actual true strength is of the structure.
Certainly. And that just goes further into the statement that the cylinders, albeit the traditional way we've done it, they've never represented the pavement.
Hmm.
Um, Even when you have ideal conditions for curing, say you're pouring on a 65-degree day and it stays that way,
Yeah.
that cylinder will cure in ideal conditions until it gets taken back into the lab, but
Hmm.
it still doesn't represent the strength that's happening in the pavement with the heat and the mass. So you may get a break that passes, but it's not telling you what's down on the
It's
ground.
really down there, right? Yeah. Which is interesting. And you mentioned heat, but we hear this thing from the northern states when they're still pouring up in the fall, and now you get the cold days that are coming in, and they're throwing blankets on, they're trying to warm it up and light a fire and do all sorts of crazy things, right?
Yep.
So,
Yep.
yeah, it's challenging. So I mean, and that's where I think maturity came on board was a
Hmm.
big help because it was real time and it measured the temperature of the structure,
Yep.
albeit you had to calibrate it to cylinder breaks and you still had to do cylinder breaks. So it was a little bit better, but not the best.
Yep.
So, we think that the Rebel system is one that solves a lot of these problems, doesn't require calibration. It gives you real-time data. it's independent of the heat of the structure, it's independent of the moisture of the structure. It gives you a more truer value of the strength of the concrete as it's curing because we're really kind of measuring the modulus of it and then converting that to compressive strength.
Yep.
Uh, I know you've used our product, and we're going to talk a little bit about that. But how did you first hear about the Rebel?
I think it was 2022. I was in Nashville for a National Concrete Consortium conference, and I believe that was the one I heard Luna first present at. May have been the one before that, but it was at an NC Squared conference.
Okay.
And as we've discussed in the past, I'm one of those people having spent an entire career out in the field,
Mhm.
understanding the challenges and whenever you hear something come along that addresses a real opportunity for answers for questions we didn't have answers to. My ears certainly perked up, and then she, of course, went through the history and the research and development, and this was a very intriguing thing that I wanted to learn more about.
Yeah, that's great. And then ultimately, you started using it. You were one of our early adopters of trying it out in the
Yeah.
Missouri area and St. Louis area. So, tell us a little bit about, how you've been using it, projects
Mhm.
you use it on, and then maybe some of the feedback that you have in its use.
Sure. So we I'll kind of go through a little bit of the results on one of the projects we did last year, supporting a local city. We decided to go out there and we put two sensors in. They had a project pouring some subdivision concrete, slab replacement, and we went in there and did two cylinders, or two sensors, one at the beginning of the pour and one at the end. We were checking a lot of things throughout this project. We were also using some nanosilica technologies and some different things. So what we experienced on that job was that the two sensors, when averaged, and they were spread out over about 2 months, the
Mhm.
pours, on average, that was within, I think, 200 psi of all 28-day breaks across the job. So that
Mhm.
was kind of an interesting thing. First sensor that we put down was on the last hot weekend of the year. It was the
Mhm.
end of September, and we hit one of them really nasty days. And it was like 93, but just horribly felt terrible. No breeze, anything. So those are some of the times where the cylinders that sit out there for a while may end up with an issue. That
Mhm.
historically, if you're going to get it, that's one of the better chances. And since they poured that on a Friday, we know those cylinders sat out there till Monday. So past the 48 hours, that
Mhm.
whole weekend was just as hot.
Mhm.
So that sensor actually broke about, or that sensor actually read about 500 psi higher than the cylinder break at
Mhm.
7 days, which we expect.
Mhm.
That's something that I did expect, and it kind of held true. The last one, I think it was on the 28 days, it was about 300. The sensor was 300 below the break.
Mhm.
So again, right there. And when you averaged all of it out, they were right on top of each other. So it turned out to be a good correlation.
Mhm.
And certainly as we get more and more of those, I would expect in ideal ambient temperatures, the cylinder and the sensor are going to be pretty close to one another in
Mhm.
results. And that has been our experience, so that we can validate it and we can accept it when we get into the hot months or the cold months or the odd times where we know we've historically had more fluctuation and reliable results, that the sensor is telling us what really is there.
Yeah, yeah. And ease of use, I mean, have you found it to be fairly straightforward in terms of deploying?
Yep.
Any any gotchas there that you would say like, oh, should have done this different?
No, being on flat work, it's really easy to do. We have put it in some structures recently for members, and it's very easy for them as well. You just put it in between the steel overlap.
Mhm.
They use some nails and pop it into the bottom wood forms,
Yeah.
hold it about an inch off the ground, and very, very easy to install, very easy to use. Data loggers, keep them charged. You'll get a few weeks out of the charge, and then you need to come out and swap them out. Or you can just plug it in, plug it out, coming as you please, and
Hmm.
use the loggers in other places. But very, very user friendly.
Yeah, that's great. So in flat work, we're selling it for in multiple applications. Of course, doing the pavement. Patchwork is becoming more popular. Um, bridge decks.
Yep.
It's a nice use there. Overlays, we're starting to look at some work with overlays, although the sensor isn't good to actually put in the overlay, but we have a product, the cylinder sensor product, which we put a sensor in the bottom of a 6x12 cylinder, and you fill the cylinder up with about 6 inches of concrete, and then it can sit by the side of the road and correlates pretty well to a 2 to 3 inch kind of overlay without actually having the sensor in that structure because a little thin. We need about 4 inches of concrete over that sensor. Have you done other projects than just, let's say, pavement with the product?
The last one, well, the one we've got active right now, still waiting on 28-day results, is a parking garage. So that's a
Okay.
bridge.
Yeah,
I
yeah,
mean, that's
yeah,
what
decking in that. Yep, yeah,
yep,
absolutely. About the
that's
same
what
thing.
we're doing out there. And that one's kind of interesting. So we have two sensors in there, and I wasn't able to stay all day. So by the time the concrete got over them, I was gone. But the project manager was going to try and make sure that the testing got done at the same time that material was going to go over the sensor.
Mhm.
Well, I think only one sensor got covered with that truck because here was
Mhm.
the interesting results. We ended up getting a 7-day break of, I think we were looking at around 4,000 PSI or something like that. And the sensor, one of the sensors, oh no, yeah, we had 5,100 PSI. One of the two sensors was reading exactly 5,100 at 7 days. And then I'm sitting there and I'm like, well, I think I know where this stuff went. The other one was reading 4,500, so about six lower. If you average those two, if they did have the same concrete,
Mhm.
possible. But we got a break in, and one of the two sensor readings were identical to the break reading. So that was kind of cool.
Yeah, that's kind of interesting. That's great. We don't often see that happen. I mean, we say our accuracy is within, plus or minus 15%, or usually under 500 psi of the break
Sure,
at 28 days. So there's a variance in there, just like there is with cylinders,
sure,
right? Which is why we do multiple cylinders. Yeah,
sure. And we
that's
have tried this in unique applications just to see what if.
oh,
So
okay.
the full depth reclamation, that's a that's a probably going to be a big market at some point in time, but we don't have a
Sure.
way to test the strength of that. We don't
Right.
have any good way to test the strength of that. So we played with it and had some fun with it. We called you guys, said, hey, this it's probably not for that, but sure,
Yeah.
let's see what happens. So
Yeah.
yeah, so that was fun.
That's good. Let me comment on that for just a second. We've we've come up with four distinct bands that our product will work in. We started really with what we call the horizontal band, and if we look at 28-day strength, we classify that between about 3 and 6,000 psi. Um, the precast market that we're selling into now, their 28-day strength tends to be between about 6 and 12,000 psi, mainly because they load it up with a lot of cement to be able to get it to cure quickly and then open their molds, right?
Yep,
They don't really
strip.
need that much strength, but it's more about process. And then we're working with some ultra high um, precision concrete, UHPC, and that goes from like 12 to 20,000 psi, and that's being used in some newer applications now. And then finally, we actually are hitting that lower band between 500 and 3,000 psi, and we've had some really good success with um, roll compressed concrete and now looking at FDR applications as well.
Yeah.
So yeah, one of the things, and we go from market to market depending on what our resources are, and retraining our model. As you know, we use
Yep.
a machine learning model that is the more data we get from breaks and projects, it gets continuing to be fed in so that our model gets tighter and tighter as we move forward. But we also found that it was smart to break the model up into these four distinct bands so we can do these things. And between RCC and FDR, where there really isn't a good way to see that strength, we're
Yep.
starting to work with partners, and we're looking for more partners in these areas that can do some specific testing. We have partnership programs to test with them to gather the data so that we can feed the model and get more accurate results for the rest of the industry. So
Definitely.
yeah, we're interested in those.
Awesome. Awesome. So yeah, that's kind of the experience.
Good. Yeah. And so, let's look at the big picture. I mean, does Rebel have a chance to compete in this marketplace? I mean, how do you, we like to think that it's cost competitive. Our product pricing has come down to be competitive with maturity sensors and we think about half the cost of making cylinders. Of course, our ultimate goal would be to eliminate cylinders altogether. Um, and we can go the distance where maturity is really good for early strength. We're good for early and late strength. But how do you see it being rolled out into the community?
Right now there's already some local cities that are putting it in their specifications around here, um, allowing the contractors to use it. Now I think they're still using cylinders as well. So this is a kind of, we'll call it a transit, maybe a transitional period, but certainly a period where this information will be allowed. I
Yeah,
think we have enough support and confidence now to realize that we are getting some information that can be used for early opening to traffic, for early stripping, and it all comes down to in the DOT world and places like that.
right.
The whole model's been based on PSI from cylinders at 28 days, and there's bonus and there's all kinds of things that get tagged to it. So this will in some ways probably rewrite the rewrite the playbook, a little
Good.
bit, but for now using it out on site, I haven't heard of anybody who's against allowing it. It seems like it's a technology that everybody is willing to embrace. Where it lives in the future of acceptance,
Hmm.
is the evolution that will come.
Yeah, yeah. We've had 100-year history with cylinder brakes, and Rome wasn't built in a
I,
day. We now know because it took so long for them to get cylinder brakes done.
they had to wait for cure
Uh,
time.
So yeah, and we're not going anywhere. I mean, we've been out in the market now for 2 years, and we're getting, I think, good traction all the way around. We've got uh, 35 states, I think, engaged right now in testing and
Hmm.
potentially writing our AASHTO specification into their state specs, which would be really exciting. And
And,
yeah.
and I think a big part of this, before we lose people, is whether sustainability is the push or not the push. Economics is a push and always will be a push. And as materials change, we get new cements in the market, we get new admixtures, we, we really probably should be starting to look at a more reliable way to test what's in place, because
Mhm.
we're going to start taking away some of those factors of safety, the cement, whether it's for economics or sustainability or it's supply.
Yeah.
Those things are realities, and we've lived with big buffers for a long time. And I'm
Mhm.
not so sure that those big buffers didn't cost us some durability and some long-term performance. And I think
Mhm.
we're starting to understand that now. So what we really want to know is, what is the material on grade doing? And
Mhm.
and these are going to give us that much more comfortable step. As people start using these and see what I've seen, you're
Mhm.
going to get very close results to those cylinder breaks, to the point where which one is more accurate, who knows?
Hmm.
But they're close enough to say that this can tell me what that's telling me.
Hmm. Yeah,
And if I start cutting down my cement to 500 pounds a yard, I'm going to want to know, I want to know what the pavement's doing, not what the
right.
cylinder's doing.
Yeah,
Mhm.
yeah. Very, very good points. Well, I think that that's a great wrap for right there, Jesse. Thanks so much for your information and background and color to our product and the use of it. We really appreciate that. Um,
Absolutely.
so, Suzanne, maybe we can open it up to any questions that might be out there.
Yeah, we've had a fantastic session. So if anybody's got any questions, I don't see any at the moment. But we sure had a great conversation. Is there anything else you want to add in, Joe?
Jesse, or that. Well, let's ask one off the court question, and that's
I'm
let's talk about
gonna
one
call a
L.
foul on
That's
this.
right, a foul. We go a little foul. How about one L? How's one L treating the industry? I know there's been a lot of ups and downs on that.
You know, it's like any other change. You know, we've changed cements throughout the years. We went into using the chemistry of cement changed, and then we started adding the supplementary cementitious materials, which
Yeah,
changed it. And now the 1L has brought another round of change. And all that really means is that we probably do need to spend a little more time on the front side doing our trial batches, seeing how admixture A reacts versus admixture B, because it's going to be a little different. And I think we all felt like that there was going to be no impact, right? We were just going to
yeah,
change and
right.
everything would go the way it always went. And it maybe 80% of the time that was true, but 20% of the time there was some things noticed, and the way we always did it didn't get us the result we always got. So that tweaking now of really understanding our mixes and taking a step back and making sure that what we're doing today is the right thing for today. That that would really be it. It's just due diligence is what it made us take a step back and revisit.
Yeah. So a lot of changes for sure. I mean, we went through last year and the last couple of years looking at low carbon concretes, and of course that we've now changed to kind of durability, and I think that's all good steps in the right direction, as you said. Uh, one of the things that we think helps support that when you have to go through all these changes and there's nothing certain, to have a bigger toolbox that can help you look at some of these things. And we're hoping that people see the value of the Rebel sensor in kind of having a new tool in their toolbox to
Yep.
look at how those differences, when you start changing the mix design a lot, you don't have to calibrate it. Just see what happens with the sensor, right? And see what the data, how that changes the mix. And so it's a
Yep.
coming together.
Yep. It's been extremely close to the results that we're getting from the cylinder. So it is validating to me to see this, to those that are coming out and witnessing and watching, that my interest again comes deeply into those June, July, August time frames where we've just got a whole history of all of a sudden our mix isn't no good anymore. Wait,
Yeah,
what?
that drives you crazy. Yeah.
Maybe the sample? So,
Uh,
so yeah, no, I would encourage everybody to absolutely try this. Try it during the seasons when you expect your cylinders to break normally. Get your comfort level that you're getting results right on par with that. And then I would use it as a belts and suspenders when we get into things like bridge pours, things you can't get back into
mhm.
very easily. So maybe you
Right.
do your cylinders, but let's also have another measure in there. And if you want to know the temperature, a lot of times
Yeah.
we need to make sure our concrete's not freezing or it's
Yeah.
not getting too hot because we got mass pours.
Mhm.
So very, very useful technology.
Yeah. Well, again, Jesse, thanks so much for your comments and your insights here. It's been a lot of fun working with you, and we look forward to working with you a
Absolutely.
lot more. So,
Yeah.
Ditto.
And thanks to all our attendees and their time and participation. And we hope you found this helpful. And if I'm not wrong, but I think the two of you guys have a pool match you need to schedule.
Oh,
A
no,
match,
no,
right?
there it
Elaine?
is.
Yeah.
We have
We're not
two.
going to talk about who won the last time and who's
All
up
right.
or down,
Well,
but
maybe we'll
Jesse
have to
is an
schedule
awesome
that.
pool player, let me
Th
tell you.
this is a bad time to let Joe know. You always throw it when you're talking with a new client.
I can't help myself.
All
Oh
right.
man, Joe is a good pool player.
All
Don't bet
right,
against him.
gentlemen. Thank you for your time today. We really appreciate it.
All right. Thank you,
Bye-bye.
Suzanne. Bye bye.
Okay, we'll see everybody.